we can use the sum and difference identities for sine and cosine and tangent to help us with our verifications as well. So here we have an example. We're asked to establish each identity, or basically verify that the statement given is true. So we want to verify that cosine of pi over 2 plus theta is equal to negative sine theta. So I'm going to start with my left side, which is cosine of pi over 2 plus theta. Okay, and of course we've got the cosine of the sum of two angles. And so we're going to use our sum formula for cosine, which if we write it out, and I'll write it out here above, is going to be cosine alpha cosine beta minus sine alpha sine beta. Okay, so when I look at this, alpha for me is going to be pi over 2, and my beta is going to be theta. All right, that may help, and if that doesn't help, then just ignore that part. But when I write this in terms of the two angles given here, we get cosine of pi over 2 times cosine theta minus sine of pi over 2, because that's my alpha, times sine theta. Okay, so my next step then is going to be to evaluate the functions that I can. And of course I know that cosine of pi over 2 is 0. So we've got 0 times cosine theta. And sine of pi over 2 is negative 1, is 1. Not negative 1, just 1. Okay. And so, of course, 0 times cosine theta is 0. And then 1 times sine theta is sine theta, but we've got the minus here. So we find that it is indeed equal to negative sine theta. All right, we can use similar procedures to verify our next problem. We want to verify that sine of alpha plus beta over cosine alpha cosine beta equals tangent alpha plus tangent beta. So again, I'll start with the left side. I've got sine of alpha plus beta over cosine alpha times cosine beta. Okay, well, I'm going to go on and expand my numerator using my sum formula for sine. So that gives me sine alpha cosine beta plus sine beta cosine alpha. Okay, all over cosine alpha and cosine beta. Okay, well, since I have a single term in my denominator, remember terms are separated by plus and minus signs. So in my numerator, I've got two terms. Okay, this is one term and this is the other. But in my denominator, I have a single term. I can distribute that single term to each term in my numerator. So we get sine alpha cosine beta over cosine alpha cosine beta plus sine beta cosine alpha over cosine alpha cosine beta. Okay, again, I'm using a distribution property. If we have A plus B over C, that's equal to A over C plus B over C. Okay, and so cosine betas, they cancel out. we get sine alpha over cosine alpha, and then sine beta, cosine alpha over cosine alpha, cosine beta. The cosine alphas cancel out. And so we're left with sine beta over cosine beta. And of course, we know sine over cosine is tangent. And so we have tangent alpha plus tangent beta.